Data partitioning, the key to scalable systems. Master sharding techniques and strategies. Imagine your system is booming. Millions of users, non-stop requests, and an ever-growing database. Sounds exciting, right? But here's the catch. Without the right design, your database can become your system's biggest bottleneck. The solution: data partitioning, also known as sharding. It's the secret sauce behind the scalability of tech giants like Google, Meta, and Amazon. And today, I'll show you how it works, why it's crucial, and the strategies you need to master it. At its core, sharding is about splitting your data into smaller, manageable pieces, or shards, to improve performance and scalability. Instead of one massive database struggling to handle everything, each shard operates independently, sharing the load. So, why should you care about sharding? Here are the big wins. Firstly, scalability. Sharding lets you handle massive growth by adding more shards instead of overloading one database. Secondly, performance. With smaller focused shards, query times drop significantly. Lastly, fault isolation. A problem in one shard doesn't bring down the entire system. Think of it like dividing a pizza. You're not just feeding one person, you're sharing the slices so everyone gets a piece. Now, let's talk about how to shard. Here are 3 common strategies. First, horizontal partitioning. Split rows across shards. For example, users with IDs 1 to 1000 go to shard 1, 1001 to 2000 to shard 2, and so on. Second, vertical partitioning. Split by columns. Store user details in one shard and order details in another. And finally, hash-based partitioning. Use a hash function to distribute data evenly across shards, preventing imbalances. Each technique has its pros and cons, and choosing the right one depends on your system's requirements. So, how do companies use sharding in the real world? Twitter shards tweets by user ID to handle billions of posts seamlessly. Amazon partitions product catalogs by category for faster search and retrieval. Netflix uses sharding to distribute user profiles and viewing history across regions. Sharding isn't just a design choice. It's the backbone of scalability for the world's largest platforms. But sharding isn't all sunshine and rainbows. It comes with challenges. First, cross-shard queries. Queries that span multiple shards can slow down performance. Second, shard rebalancing. When a shard grows too large, rebalancing data across shards can be complex. And third, data integrity. Ensuring consistency across shards requires careful planning. Here's how to avoid the pitfalls of sharding. Plan your shard keys wisely. A bad shard key can lead to uneven data distribution. Automate shard rebalancing with tools like Zookeeper or Shard Manager. Monitor your shards regularly for hotspots or anomalies. Sharding is like building a skyscraper. It's all about having a solid foundation and scalable design. To recap, first, sharding divides data into manageable pieces for scalability and performance. Second, horizontal, vertical, and hash-based partitioning are your go-to techniques. And third, plan, monitor, and rebalance to keep your system running smoothly. Want to take it further? In the next video, we'll explore replication versus sharding, and when to use each for maximum impact. If you're ready to scale like the pros and future-proof your systems, hit subscribe, turn on notifications, and join me for the next episode. Because in system design, the ability to scale isn't optional, it's survival.